How are you, everybody who is watching this video? I'm very happy to have you today, and I would like to take this opportunity to welcome, to join us anywhere, at any time, concerning about the business that we have. If it's the first time to meet me, my name is Olenjolai. I thank God by His own grace. He has given me a gift of teaching, and especially teaching the beauty of telecommunication engineering. So I would like to take this opportunity to welcome you about one of the course or one of the modules we used to teach our students that we used to train them physically, that's called the radar and navigation system. So this course actually is very fundamental. It will actually transform your mindset and it will show you the applications of the different physics concept, especially in case of the light, because you have been learning about light spectrum, but possibly you have never known about where are we using that light spectrum. So it's very interesting modules. For instance, myself, I learned these modules 9 years ago, and I enjoyed it much. However, that I learned in my first year, and also I learned in the second year. So these programs is very interactive. We are very serious in this business. We ask you to have a fresh mind, have your exercise book, have your pen, have your pencil, because today in this workshop or in this lecture, we are going to have some drawing. So it's better, or a competent or a good technician, it's a one who used to write by using a black or white pen and draw by using a pencil. So you should also have a rubber and should have a fresh mind in order to receive what I've prepared today. In case you have any question, you may ask at the beginning of the class, or even the mid of the class, or even at the end of the class. Then we record these contents for the online community, or in order to teach some other students who we cannot teach them physically or face-to-face. So whether you are in this class as a physical student or online student, get prepared, because this lecture is going to transform your life. One precautions that I would like to give you, because in engineering we have safety and precaution. So the one important precaution that I would like to give you is Olenjolai does not know everything about radar and navigation aids. I just know small portions of it, but I have a responsibility to teach others about telecommunication engineering. I'm always learning new concepts about telecommunication, because learning it's a journey and learning is a part of my life. So I have some physical students. Before we start our today's lecture, let me appreciate your presence. How are you, students? How are you? Okay, are you ready for today's lecture? Yeah, so let us get into lecture 2. Let us do the quick review of lecture 1. So in lecture 1, I have just introduced you about the prerequisite module. Prerequisite module for this module called radar navigation aids. So the prerequisite modules is called transmission what class? A radio transmission. So radio transmission system. And its module code, it is ETT 05, pardon? 01. 111. That's the module code for at the prerequisite of this module. Then we present to you about the learning context. Learning what? Context. So the learning context, we say that, what the learning context? Pardon? So we can teach you these modules by using lectures, by using what? Practical works, by using what? Assignments, by using what? Tutorials, and by using what? Study visit. So study visit, it's another, or it's one of the learning what? Context. Then I presented to you about what are the learning materials that we need to learn radar and navigation aids. Learning material, blackboard or white board. This is one. Then we need what? Multimedia projector. Then we need what? Written what? Written study materials. Written study materials. Wonderful. Then I present to you about references. And I present to you about two types of references. The first one is called what? Required. It's called what? Required references. And how many were they? 2. And in these required references, what are the names of the first required references? Pardon? I say the name. I didn't ask you the author. Modern Radar. So the name of the first reference book is called the Modern Radar System. Then the next one, Principles of Modern Radar. Principles of Modern Radar. Then the next one, that's all. Then I present to you Roman B, which is what? Recommended what? Recommended references. So how many recommended references did you have, or did I introduce to you? 3. The first one, radar system and the radio navigation. Radar system and the radio navigation aids, right? The second one, the second recommended reference, Introduction to Radar System. And the next one, Introduction to Radar System. What the difference between the second recommended reference and the third recommended reference? Edition. So it means that the second one, what is edition? Second edition. Very good. And the other one? First edition. Then I left the homework to you. And the homework, I ask you to download at least 1 required references. So students, did you manage to find at least 1 required reference? Did you download it? So you have it. You have it. Where did you keep it? In your mobile phone or on your computer? In your mobile phone. So is it in the folder of the movie or the new folder? It's far away from the movie, because download. Okay. Then I left another question that download at least 2 recommended references. Did you make it? So what did you get? How many did you get? Others 1, others 2 recommended references, and others none. So it means at least 2. So is there any students who have got 3 recommended references book or reference books? No. So maximum it is 2. And then what did you notice? You noticed that some of these reference books are not free. You have to purchase them. So ask your neighbor, did you purchase one of them? Okay, so if that's the case, in case you missed this content, should not worry. We have recorded a video about lecture 1, very interesting one, and it's already in air. So you may go through it. So today, let us keep on, or let us start a new topic, which is called the Introduction to Radar System. Introduction to Radar System. Introduction to Radar System. Radar system. So this is according to the first sub-enabling outcome. So introduction to radar system. Students say introduction to radar system.
Introduction to radar system.
If you remember the first sub-enabling outcomes, actually it states that a student has to employ knowledge, has to employ electronics and telecommunication knowledge and skills in order to interpret parts of the radar system. So in this topic, we'll be focusing on the parts of the radar system. Are we together? So let us go straight forward into the business. And we are going to have, I will teach you almost 60 terminologies that we are often use them in radar system. And the first terminology, let us understand what we are learning. Because the name of the module is called the radar system and the navigation aids. So we'll start with the part of radar system, and later on I'll teach you about 30 navigation aids in the next lectures. So we have the first terminology, very important terminology, because this is the one actually that makes us to meet together and make us to enjoy this business. And the first terminology is called the radar system. Say radar system.
Radar system.
Again, say radar system. The aim to ask you to mention is actually to reinforce their understanding. So, what is radar system? If somebody, actually, if maybe you have a friend who is studying in another institution, so another college, and then say, you met together, or you had a phone conversation with him or her, and then you share that, oh, you know, in this semester, I have a module that called the radar. And then your friends ask you, what the means of radar? How are you going to answer that question? Will you? You'll say that we didn't cover it yet. So, what is radar system? There's a different sources or references that used to define this terminology, but I preferred to choose, or I will give you the 3 definitions of the word radar system because it's a very powerful word. Radar system, students say radar system. So radar system is a system. So this is the system. We say it's a system that uses radio waves to determine the distance. Determine the distance. Shortly, this distance, in other words, we call it range. Range. Also, radar can determine something, we call it direction. And then we have those 3 directions: azimuth and the elevation angle. The elevation angles. That's what it means in case of direction. Elevation angles. And also radar system uses radio waves to determine radio velocity. Radio velocity. Radio velocity of objects relative to the site. This is the first way or first definition of the word radar system. Radar system is a system that uses radar wave. It uses radar waves to determine what? The distance, which we call it range in radar. We call that distance, we call it range. Also, radar systems that determine direction. And this direction we call them azimuth and elevation angles. And also radar systems determine the radial velocity of the objects relative to the site. Very powerful definition of radar system. So operating, listen. So before I ask you to pronounce it and write in your mind, because remember that we don't teach students, or I will never teach you how to claim the stuff. I will teach you how to understand them. So there's no need for you to claim the words and to claim the definition. There's no need. Just what you have to know, keywords in every term or in every definition or in the kinds of the explanation. What are the keywords? And then the rest, you use your own vocabularies. Are we together? So radar system, we say that this is the system, is the one of the system that we have in telecommunication engineering that uses radio waves. It means without radio waves, it can't work. So it uses radio wave for three purposes. The first one, it uses radio wave to determine distance or range of the object relative to the site. The second one, radar is a system that uses radio waves to determine direction of the objects relative to the site. And the third one, radar system is a system that uses radio wave to determine radial velocity of the object relative to the site. So that's the meaning of the word radar. Students say radar again. Radar. Say radar. Radar. So it means that these are the actual, it means that you can write this definition, make it longer as well as you can. But this is the way that you can write it in short. So simply, a radar uses radio waves. Say radio waves. Radio waves. Say radio waves. Radio waves. And you remember that the names of the prerequisite module is what? Radio or radio transmission. So you've been learning how to transmit radio waves, right? So once you've understood how to transmit radio waves, and then now we are teaching you where do we use those radio waves, or where are those radio waves have been used in telecommunication. So they have been used in what? Radar system. So it uses radio waves to do what? One, to determine distance. Say distance. Distance. Say distance. Distance. AKA range. Say range. Range. Say range. Range. Range, distance or range of what? Of the object. It can be one object or a number of the objects. But not just to determine the distance of the object, relative to the what? To the side. When you hear the word relative, we introduce our student the word relative in the topic that called the scalar and vectors, which is the first topic of physics from 3. So that the moments when we teach that are about relative velocity, if you do remember. For me, that's the first time when I met the word relative. So we don't mean about relative as your relatives, maybe the people that you have blood relationship, no. Then we say that this also radar system uses radio waves to determine direction. Say direction. Say direction. Direction. Actually, we can define directions as maybe that if I'm at this point and as I want to go that point, I can say that either north or I'm heading to south or to west or to what? Or to east. But direction in mathematics, engineering, and science is defined in terms of what? Angles. Right? So whenever you talk about directions, yes, you can talk about direction. But if I say that, for instance, I want to move toward east, then the next question, what the angle of your direction with respect to the reference point? So if, for instance, I'm moving from west towards east, so the angle there, it's 180. If, for instance, I am moving from east, I want to go to until a particular point, then I start to move to south, right? The angle there is 90. Okay? Okay? So you have to understand. That's why we've been teaching about vector. Because we told that vector, what is a vector quantity? It's a physical quantity which has what? Magnitude and the direction. By that time, we taught you directions as maybe moving from one point towards another point. But nowadays, we are adding the value. When you talk about direction in engineering and science and mathematics, we talk about angles. And we talked about trigonometry, which is the branch of mathematics. This is what? Sides of the triangle and what? And angles. Okay? So those direction or that direction, it has a particular name. We have azimuth angles and the elevation angles. Say azimuth angles. Say azimuth angle. And the elevation angles. Yes, in basic mathematics form 3, we taught you about the elevation angle and the depression angle. In which topic? Huh? Pardon? Planets and the planets and the elevation. Plane? Plane? Okay. Then we say that, so but we are determining, or it can determine directions of what? Of the object, single object or more than object, relative to the side. Relative to which side? It means the reference there is the place where the radar is. Okay? Okay? But also radar system uses radio waves to determine what is radio velocity. Say radio velocity. So in physics and science and engineering, we have radio velocity, we have tangential velocity, we have angular velocity. So we have different terminologies of velocity. Hopefully what you see, remember, just velocity is equal to distance over time. That's all. And you've been navigating with that. But you have never bothered yourself about other types of what? Of velocity. So radio velocity of what? Of object. Relative to what? To the side. Are we together? So 1, 2, 3, let us read it healthily. Radar system is Again, you ready? Actual, very, very, very poor. Again, 1, 2, 3. Let us go. Good. Ask your neighbor. Did you understand? Ask your neighbor again. Did you understand the definition, the first definition of radar? So this is the second way that you may define the word radar system. That's the second way that you may define the word radar system. Also, this is the third definition of the word radar system. Okay, so we have three definitions of the terminological radar system on the blackboard. And stop writing. This is the time for me to explain them. Then we have to go to the next terminology. The second definition, we may define radar. Radar system is an electromagnetic sensor. Say electromagnetic sensor. Say electromagnetic sensor. Used for detecting, say detecting, locating, tracking, recognizing objects of various kinds at the considerable distances. So, firstly, radar system is electromagnetic sensor. What does it mean? It means a radar system, it senses. It has ability to sense. Say sensor. A human body is actually overwhelmed with the number of the sensors. Right? If you want to understand that your body is surrounded with a number of sensors, just try to push your neighbor. Just push your neighbor. Push your neighbor. Then so what happened? You find that she's resisting your push. Why? Because she used a sensor called the eyes to see what you want to do. But also because I spoke it, she used a sensor that called the ear. Right? And then send the message to the brain. That is control unit. Afterwards, then the brain say, okay, no, resist that push by doing this one. I say it is a time for me to explain what I have wrote on the blackboard. Can you check your neighbor? What is he or she doing? Do you see? Do you see your neighbor? The other one. Do you see? Those are the Olenjolain students. If you ask them to listen, that's the time for them to write. They always go work inversely proportional, or vice versa, or inversely. Stop writing, they are writing. Write, they don't write. So this is the electromagnetic sensor. It means that it can sense electromagnetic waves. The word electromagnetic is a combination of the two words, magnet and the electrical. So the word electromagnetic, electro, means electricity. Magnetic means magnet. Okay? Yeah. So it is a sensor that detects what? Electromagnetic waves. Then use it for what? Why do we have this sensor? This sensor, we use it, first of all, detecting what? Objects of the various kinds at the considerable distances. So it does not detect just an object, but should detect or should be able to detect an object at a distance, not nearby objects. So at a distance where the human eyes have limitations or have limitations to see or to detect that object. Okay? Okay? So this also, electromagnetic sensor is used to locate, actually locate objects of the various kinds at the considerable distances. What does it mean? For instance, if you use radar in navigation, or for instance, actually to establish the communication between the pilot and the air traffic controller. So it means that radar can be used to position. It means that to tell the pilot that now you can go maybe some miles. Maybe you can go some miles up or some miles down. Okay? That means of 40 you can locate because the space does not have a physical structure. But also this electromagnetic sensor is used for tracking. Say tracking. Say tracking. For instance, you hear that some of the aircrafts they use to get lost. Maybe an airplane or maybe a rocket, but it used to be to get lost, right? So the radar system may be used to track that object. And then this one, radar system as electromagnetic sensor, it can be used for recognizing objects. Say recognizing objects. Say recognizing objects. For instance, an aircraft cannot take off from Nairobi International Airport to Mwalimu Julius Kambarage Nyerere International Airport without the recognition, the official recognitions of 40 of Air Army. So it means that any airplane that passing through the boundaries of Tanzania, it can be recognized by using what? Radar. Are we together? Are we together? Including the ocean. Physically, you can see that the ocean does not have boundaries and it's huge. But that is according to what you know. But I want to tell you that nothing is not under control. The space is under control. The water bodies is under control. Okay? So that is. Then the third definition is a radar system. This is the detection system. Detection system that uses radio waves to determine. So uses radio waves to determine what? Determine distance, determine angle, determine radio velocity of the object, but relative to the side. So there's a close relationship between the first definition and third definition. But the second definition is actual expanding your understanding. Because if I've given you only the first definition, you could not know about tracking, you could not know about locating, you could not know about recognizing. Are we together? So all of these all of these three definitions actually give you more information about radar system. Are we together? Yes. Is it clear? Yes. Did you understand? Any question about radar system, about definition of radar system? Ask your neighbor, did you understand the definitions of radar system? Ask loudly, did you understand the definition of radar system? So what did your neighbor say? Somehow. Others somehow, others yes. Okay, so if it's somehow, just go and review or watch this video several times until the concepts build in your mind. Are we together? Yes. So the next part, let us come back to the first definition. I said it's stop writing. Stop writing, stop talking. In the first definition, we find also 5 new terminologies, which are very important. The first terminology in this definition, we find a word called the radio waves. So radio wave, it's a broad terminology. In cellular communication, it means mobile communication, we use radio wave. Right? When we talk about radio communication, radio, it means voice communication. We use what? Radio waves. When you talk about television, right? Just the transmissions of television signal. Or yes, television signal, videos and whatever. We use radio waves. So when you mention about the word radio waves, we should be specific. Radio waves of which frequency? Right? So the second terminology here, we have to understand about radio waves in relation to what? Radar system. Okay? Okay? Then the next terminology is called the range. This is the vocabulary. We have the word called what? Range. Say range. Say range. Say range. I think that you used to see some cars in towns written Range Rover. Could you relate Range Rover and the range in radar? So range. So this is another vocabulary that we learn or we have to dig in it. Then the next vocabulary is, direction is not a new vocabulary for us, but this azimuth angle and the elevation angle, these are the new terminologies. So the third terminology is azimuth angle. Say azimuth angle. We should know what does it mean about azimuth angle and how do we determine it and how radar use it. Then the fourth terminology is called the elevation angle. Say elevation angle. Say elevation angle. And then the fifth terminology is about radio velocity. Are we together? So now let us start with the first vocabulary that's called the radio wave. So radio, say radio waves. Radio waves. Say radio waves. Radio waves. So we have a second question here, which is very important. Oh, before I teach you about this second terminology, let me just reveal or open your mind. The word radar is abbreviation so the word radar, say radar. The word radar is abbreviation of the word radio, which means this one, detection, radio detection, and the ranging. So radar, it's abbreviations of 40. Radio detection and ranging. Say radio detection and range. Say radio detection and ranging. So we may not call it radar. We may call it radio detection and ranging. So even our modules, we may call it, the name of the modules that we are learning is called the radio detection and ranging and navigation aids. So radar, it's abbreviation. Say abbreviation. So the word radar, RA, represents radio. Right? A. Then D represents detection. Then R represents end. Then R representing ranging. So simply to remind you, because I know that it's very simple for you to get confused. Radar is equal to radio, detection, radio detection, and the ranging. And the ranging. So radar represents radio detection and what? Ranging. That's all. So also from the word radar itself, you see the first vocabulary that you have learned from its definition. That is what? Radio detection. So we have the word what? Radio. Okay? But in this also, in the word of radar, we see the second terminology or the second vocabulary, which is called what? Range. Because range, it's a noun. Ranging also it's a noun. So it means that regardless of how we can take the concepts of radar, we'll be encountering these 5 terminologies. And we should understand them before even we go to the parts of the radar system. Are we together? Yes. Are we together? Yes. Okay. So let us have maybe a simple figure. So this is, we call it radar transmitter or radar receiver. Then here we have an object. So this is the radar system. Radar system. Say radar system. Say radar system. So in the radar system, this is the dish. So this is called the radar antenna. Radar dish antenna. radar dish antenna. So it is radar dish antenna. I said stop writing. Listen. So the radar system, it has transmitter and receiver built in within the same structure. So this is radar system, and this is radar dish antenna. I said stop writing. So when this radar dish or radar dish antenna send the radio waves towards the OT, towards this incoming OT, incoming object, okay? Then it will be sending radio waves which are in this direction. So the radio waves will be sent towards OT, towards the object, okay? And then this object will be reflecting some of these radio waves. So when the radar system send or transmit or propagate the radio waves towards the distant object, by that time the receiver is off. Okay? Okay? Yeah. It's just like yourself right now. If for instance your body has it has a receiver and the transmitter. So you can find that when the transmitter works, the receiver should be, for instance, if for instance that I'm talking and you are talking, we want to understand each other, isn't it? Eh? So when I talk, my mouth acts as a transmitter. Right? So the radar system, the architecture of radar system, actually it's not new. It has been taken from what God has created in the mankind. Because I want to tell you that most systems that we have in science and engineering is just we call extension of what God has created. That might be sounding different in your mind. What does it mean? For instance, we used to have microphone. This is the microphone I wear, right? Yeah. This is the microphone. So this microphone, its primary function is to listen my voice. Right? So the microphone, the structure of microphone is the same with the structure of ear. To mine, stand up. It is the same with the structure of what? An ear, right? An ear, according to the biology, it has mainly three parts. Inner ear, middle ear, and the outer. Yes, those days you are good in biology. Nowadays, no. You say that I'm a professional engineer or a professional technician. So it means that engineers who have innovated the microphone, they just extended what God has created, because this is not created by human being. Are we together? That's the first example. Say first example. The second example, we used to have speakers, and especially in our rooms, we used to have what? Subwoofer. And you enjoy it, and you used to make sure that when you come back from DIT, the stuff are on, isn't it? Yeah, so the man is back from the college. The teenager is back from what? The college. So you put your subwoofer, and everyone has to keep silent. Okay? So simply, in case of the music system, we get the outputs of the music system by using speaker. Right? So speaker is man-made. Wonderful. But there's a first speaker which has been made so many years ago. But that is just a duplicate or just extension of the mouse. The speaker is functioning like the mouse. Now you came to listen my speaker. You came to listen what? My speaker. So my mouse is the speaker. Are we together? So let us come back. So I will just trying to give you the concept. So don't think that we used to innovate something new that which God did never actually innovate. I want to tell you that that is wrong. We just maximize or utilize or increase our knowledge, because we as a human being, we have a limited knowledge. That's why that every day, once we learn about something, we come up with a new innovation. We call it a new innovation, but actually it's extension. A new innovation in the mankind context, but it's not a new innovation to God. Are we together? Yes. Okay, so let us come back to the radar system. In the radar system, I want to tell you in advance that in the radar system, we have radar transmitter and radar receiver built in within the same OT architecture. How is that possible? Well, that is just a copy of what God has done. For instance, myself, if I speak, I'm transmitting the signal. So this is the mouth. This is the transmitter. Okay? But if I want to listen from you, it means that I have a receiver. My ear, it will be a receiver to listen you. So transmitter, receiver. Show it to yourself so you can never forget because you're telecommunication students. So short up. This is my transmitter. Show it. Say, this is my transmitter. This is my receiver. But this is biological transmitter. And this is biological receiver. I came to learn how to make electronic transmitter. And I came to learn how to make electronics receivers. That's all. So it means that, for instance, myself, if I want to transmit it, my receiver is off. Right? Then if I want to listen to receive the information, my speaker has, my transmitter should be off when the receiver receiving what? The information. That's why that, if for instance that we talk all of us, for instance now, just to talk anything, just to talk, every student in this class, just to talk. Talk loudly, just speak loudly. Hey, hey, hey. So actually, you did not understand anything. So, do you now understand radar system? Okay, congratulate yourself. 3 times. 1, 2, 3. Ongera. Imara. Wow. So don't think that radar system is something new. It's just the improvements of the human knowledge and what God has created. So that's why that you should not be surprised to see radar transmitter and receiver within the same architecture or the same structure, right? So when the radar send the radio waves, this we call them radio waves. Say radio waves. Towards the distant object. This is an object. This is an object. So then, some of these radio waves will be reflected and some of them maybe will penetrate through the object, or some of them might be lost along the transmission. So then, I would like to have, if I could have a colored. So when this one reflects, they reflect some amount of energy. So we have reflected radio. So when it is transmitting, the transmitter is the one that will be on, while receiver will be what? Off. So the receiver is waiting the incoming what? The incoming signal. So then we have what? We have a received or a reflected. That's why we taught you the concepts of radar, the concepts of light. Do you remember? How light has fundamentally 4 properties. Right? The first one, reflection. The second one, refraction. The third one, absorptions. Light can be absorbed. And the fourth one, diffused or diffraction. Okay? The other one, light also can interfere. So it means that this is actually these are the radio waves, transmitted radio waves. And here we have what? Reflected what? Radio waves. So these are the transmitted radio waves. And also you have reflected what? Radio waves. So with this case, it means that now the radar has sent the radio waves, and also it has received the sum of the reflected what? Waves. Then now it's a matter of the receiver, once it is received the information, to send to the control unit in order to interpret the information which have been formed. Are we together? Are we together? So simply, this will be our figure 1. Our figure 1. And this figure 1, we call it general radar system. General radar system. So this is the radar system, this is the object, and we've mentioned them. So now the case of range. Hello? Can you face the blackboard? You. Because I see that you are doing some other businesses. So it means that Here we did not discuss about range, we did not discuss about direction, we did not discuss about radio. We just presented the concept about the structure of radar system. Are we together? So the concept of range is actually the distance from this point to the object. And that's what we are going to discuss about. Have you understood? Okay, draw it quickly. Do you have any question at that time? Tumaini, you may sit. Okay, so let us learn about the first terminology which we have there. It's called the radio wave. Radio waves. Say radio waves again. Do you enjoy radar in the navigation aids? I'm happy to hear that if you enjoy. So this is question number 2. And here it's a question. What is radio waves in radar system? Radar what is radio waves in radar system? We may know the definitions of radio waves, but in some other system. But now we are asking about radio waves in relation to the radar system. Radio waves is the first called is the first spectrum in the light wave so the radio wave is a type of electromagnetic waves, the type of electromagnetic waves with low wavelengths, and with high wavelengths, it's longer, called longer, with longest wavelengths. Radio waves is a type of electromagnetic wave with longest wavelengths. With longest wavelengths and the shortest frequency in the electromagnetic spectrum. So radio waves is a type of electromagnetic waves with longest wavelengths and shortest frequency in the electromagnetic spectrum. This is one of the definition of what of radio wave. Or you can define the terminology radio wave with something we call it radio frequency, or we call it RF. The oscillation remember radio frequency, we still mean that radio waves. So the oscillation, radio waves is oscillation rate. The oscillation rate of an alternating electric current, alternating electrical current or alternating voltage, oscillation rates of alternating electric current or alternating voltage or alternating magnetic fields or mechanical system in the frequency range from 20 kilohertz to 300 gigahertz. So I've tried my level best to find two definitions of the vocabulary called the radio waves in radar system. But these two definitions actually teach you about definitions of radio wave in general. We did not specify yet, but within a moment I'm going to give you some examples of radio waves that we use in practical radars or radar communication. So these are the two ways that you can define the terminology radio waves in general, whether in radar system, whether in cellular, whether in television system, or in radio system, or in other systems that uses radio wave. So the first is subtracting. Radio waves, so if you use as a type, radio wave. So omit this S, which is showing that it's plural. Radio wave is a type of electromagnetic waves. It's a type of what? Say electromagnetic waves. Say electromagnetic waves. With longest wavelengths and the shortest frequency in the electromagnetic spectrum. So we taught you these concepts of electromagnetic spectrums, and I think it is a topic in physics form 4. Right? So you have a prior knowledge, especially in science. So our responsibility here is actual to teach you how do you use that electromagnetic spectrums in telecommunication engineering. Okay? Or we can define the word radio frequency or radio wave in the oscillation. Say oscillation. When you get tired and then the distance between the upper copper and the lower copper is 0, what will happen? And then you are not lying on the bed. You will be oscillating. Oscillating. So simply say that this is the oscillation rate. Say rate. Say, not rate. Rate. So it's oscillation rate. Whenever you hear a word called or any definitions that include the word rate, it means something over time. Right? What is velocity? Is the rate of changing what? Displacement. So it means that velocity in mathematical or in mathematics is equal to displacements of what? Over time. So be careful about that. So simply say that radio frequency or radio wave is oscillation rate of an alternating electric current. Say alternating electric current. Or is oscillation rate of alternating voltage. Say alternating voltage. Say alternating voltage. Or not mean that, or it means that it can be reason. For this case, it can be either alternating electric current, but whenever we have alternating electric current, we have also alternating electric voltage. And whenever that we have alternating electric voltage, also we have alternating electric current. Right? Yeah. Then it can be either oscillations of alternating magnetic fields. Say it, alternating magnetic fields. Yeah. You've been drawing that. This is the conductor. If you have a conductor and carrying conductor, you use it to draw. Here we have magnetic fields. You have never thought that, where are we using them? So it means that radio waves, it can be oscillations of alternating magnetic fields. Right? Alternating magnetic fields. Or it can be mechanical system. It means that radio waves can be moving mechanically, however that we don't use much in case of telecommunication. In the frequency range, so this is very important, in the frequency range from 20 kilohertz, say 20 kilohertz. 20. Say 20 kilohertz. 20 kilohertz. So before even I explain about this one, I think that not this point because I've never told you. Say that engineering can be summarized by the following 5 terminologies. Engineering can be summarized by using the following 5 terminology. The first one, engineering is all about numbers. Say numbers. If you want to talk about engineering, think to talk about numbers. If you cannot talk about numbers, then tell engineering bye-bye. Yes, we'll see if God wishes. And then tell law or business, you're welcome. Business, you're welcome. You're welcome. Then engineering is all about formula. If you want to speak an engineering language, you should love to speak in terms of formula and the equation. Then the third terminology of engineering is all about diagrams. Say diagrams. Say diagrams. We have a number of diagrams, and the good news that for you had a module that called the electronics drawing, where actually you have to learn about general block diagram, detailed block diagram, schematic circuit diagram, where that you have to learn about schematic analog circuit diagram and schematic logical circuit diagram. You have to also learn about the flowchart, right? Algorithm. So whenever you want to talk about engineering, think about diagrams. If you dislike diagrams, then tell engineering bye-bye. We'll meet if God wishes. Number 4, engineering must be presented in terms of, or the information that we present or we measure or we learn in engineering or we calculate, we have to present them in terms of tables. If we cannot present the information tables, that is political engineering. Say political engineering. I want to tell you that in our country we have also political electronics and telecommunication engineering. So it's just your matter. What do you want? Do you want to be a politician in engineering? Or do you want to be a practical engineer? Okay? So we say that in numbers, formulas and equation, diagrams, tables. Number 5, that is powerful. Engineering is all about graphs. You don't like graphs? Tell engineering bye-bye. So these are the 5 terminologies that you as electronics and telecommunication technician, you should love them and you should enjoy them every day. In case you spend a week without presenting the information in engineering, in these 5 terminologies or 5 phenomena, then you are very far from the real engineering. Are you together? Are you together? Yes. So when you talk about numbers, for instance here, for instance in this definition we have some numbers. A! We have very meaningful number. The first number is 20. Very important number. Because from the first definition, the author defined it but did not take care about the range. Because this is one of the spectrum among the 7 spectrum of light. Right? So this is very important. But this is not just a number. It has a unity. Because we say any physical quantity which has a unity should be presented by using its unit. And then this is a very important number, which we did not extract it from this definition. Right? A. Then we say formula and equations. Wait, when I'll teach you about range, you'll see formula, and you'll see a number of formulas in this module. Then when we talk about diagrams, you saw that. I've explained about the concepts of radar, but possibly in terms of explanation, it was difficult for you to get the picture. But once I drew figure 1, you saw that, it's just a matter of sending the radio waves and receiving the reflected one. All right? Yes. Then when you talk about tables, we enjoy this since we've been studying science. When we've been studying physics, especially when we were in Form 3 and Form 4, we used to do some experiments, physics experiment about mechanics. We did some experience about electricity. We did some experience about light. So in any experiments that will be given or you have been given to do, you must have a table of results. You must have table of what? So you do the measurements. Once you have the measurement, you present the measure the values in what? In tables. Okay? And then next, you have been told that once you have a table, draw the graph of period against the length of the pendulum. Simply, when somebody asks you that, what is engineering? Yes, it is a very simple question. Engineering is purpose of use of science. That's all. You don't know science, it is difficult for you to learn engineering. Are we together? This is our philosophy in engineering. So when you talk about electronics and telecommunication, the philosophy of electronics and telecommunication engineering is all about we have to learn how to present the information in terms of numbers, in terms of formula and equation, in terms of diagrams, in terms of tables, in terms of graphs. Because we build this concept in mathematics and physics science that we taught in O level. Are we together? So ask your neighbor, how many graphs have you drawn since you came to DIT? I know the answer of your neighbor. And ask your neighbor, when you've been in O level, you had something we call the graph pad. Do you remember graph pad? Yes. Which consists a number of what and use the graph papers. Ask your neighbor, do you have a graph pad in your bag right now? Or do you have graph pad at your home place? No. Why? Because you have never heard that in engineering, graphs matter. Any experiments that you're doing in engineering, you fail to draw the graph, that experiment is meaningless. Because what the means of experiment? In experiments, we are doing the measurement. When you do the measurement, we are finding the numbers. And then once we have the numbers, well, how can you present these numbers? We have to draw the tables. But how can we get these numbers? We want to do experiments. We should be given a diagram. So we should have a schematic circuit diagram. Then we do the measurements, we get the numbers. Once we get the numbers, then we have the tables. Once you have the tables, we have the graphs. Once you have the graph, we have to use the formula to calculate what you have been asked to calculate. For instance, if you have been determining Or you've been asked that determine the aim of experiments, determine acceleration gravity. So you have to use this formula and a graph to calculate what the value for what I think that this is it G over L or L over G? Yes. I'm very poor in cramming. L over G. So you may use this formula to calculate acceleration gravity. That is formula. You have never think. You have just learned that this is how we do a practical, that's all. Even now, you're an engineer. You don't reason. You don't ask yourself why are you using all the formulas, all the trigonometric logarithms. Where are we using them? Are we together? Are we together? So this is the secret of science and secrets of of practical engineering. But remember, tell your neighbor, that is philosophy of practical electronics and telecommunication engineering. Tell him or her again. This is the philosophy of practical electronics and telecommunication engineering. So if you analyze yourself and you find yourself that you missed some of these parts, then you have the answer what you've been learning through. So it's a matter of yourself to change. Okay? Okay. So this is the first terminology. I think that in the next lectures I will teach you about what is engineering, what's electronics and telecommunication engineering, as just I'm adding the values. So let us come back. This is just the additional concept. Write it because I will repeat over and over about these 5 phenomena throughout this module. And whenever you meet with me, if you say that, okay, sir, let us talk about electronics and telecommunication engineering, we cannot communicate without using these 5 terminologies. So I know some of the students say, this is not a part of the module. Okay, fine. You may not or you may not. But when I will be asked you to have this stuff, then you remember them. Okay, so let us come back to our definition. Say that we are discussing about radio frequency. So radio frequency or radio wave is the one of the spectrum. So let me remind you about the electromagnetic spectrum. Then we'll come back to radar. Electromagnetic spectrum. Say electromagnetic spectrum. Say electromagnetic spectrum. Say electromagnetic spectrum. So simply we say that electromagnetic spectrum, let us remind you, electromagnetic spectrum consists 7 parts of the spectrum. Consists 7 parts. So the first one, we call it radio frequency. So this radio frequency, we call it, this is shorter, call it longer wavelengths, shorter frequency. Then the second spectrum, so this is the first spectrum. The second spectrum, we call it microwave. Microwaves. Say microwave. Microwave. Say microwave. Microwave. This one, in short, it's the one that we call it RF. And this one, we call it microwave frequency. Because frequency is the one of the measurement parameter. So for this one, we can say that microwave, this is the symbol, microwave frequency. Then the third spectrum is called the infrared. Infrared, yes, infrared frequency or infrared. This, it's short, we call it IR or infrared wave. Infrared waves. So in short, we call it IR. Then the first one, we call it visible. Visible waves. So we don't have abbreviation for this. Then the fifth spectrum, we call it ultraviolet light. ultraviolet light. Simply in short, this one we call it UV. Then the next we call it gamma. So this then we call it as gamma rays. Okay, so gamma, this is the symbol for gamma. Then the last one we call it X-ray. X-ray light. So these are the 7 spectrums we find in electromagnetic spectrum. Hello? Backbenchers there, what is going on? You're oscillating like a radio frequency. Okay, so we have 7 parts of that electromagnetic spectrum. Class A, radio wave. Radio wave. Say RF. RF. Class A, microwave. Microwave. Class A, infrared. Infrared. Class A, visible wave. Visible wave. Class A, ultraviolet. Ultraviolet. Class A, gamma. Gamma. And then say X-ray. When we talk about gamma, we know gamma because we've introduced the concept of gamma in radioactivity, which is one of the topics in physics form 4. For those who have gone for A-level, actual radioactivity also it's a subtopic of atomic physics. So, in telecommunication, we are just using 4 spectrum, or 4 parts of that spectrum in telecommunication. Because maybe you just know, but you've never think. In telecommunication engineering, say telecommunication engineering, ask your neighbor, what is telecommunication engineering? We use only 4 parts of the electromagnetic spectrum. And these 4 parts, namely, because I'm not sure that if you have this foundation, the first one we use in so telecommunication engineering, we use only 4 parts of the electromagnetic spectrum in communication systems. So these 5 spectrum, I'm still building strong foundation in your mind about radio wave and especially practical radio wave. Then I will come back to the subject at radio waves of the radar system. So the first spectrum that we are using in telecommunication is called the radio waves. Or, in short, you can call it RF. The second spectrum, it's the one that we call it microwaves. Microwaves. Then the other ones, we call it infrared. Infrared. In short, you call it IR. Then the other one, we call it visible spectrum, or visible light. These are the only 4 bands that we are using in telecommunication engineering to construct different wireless and the wired communication system. It's a secret. It is difficult for you because most of the books, they don't explain. They just explain each spectrum separately. And when they explain about infrared, actually they explain about infrared. They don't talk about some other parts of the spectrum. So let me give you this summary because I've learned this knowledge from different sources. So how many parts of the spectrums do you use in telecommunication? 4. The first one is what? A. The second one? The third one? The fourth one? Visible. So, not this one also. In telecommunication engineering, we use only 3 parts of electromagnetic spectrum to design different wireless system, wireless communication system, wireless communication system. So these 3 bands or 3 spectrum, the first one is radio frequency, which in short we call it RF. The second one we use microwave. The third one we use infrared. So in wireless telecommunication or communication system, we just use only 3 spectrums in the light spectrums to establish or to link transmitter and receiver. Okay? The first one is called what? Radio frequency. Say radio frequency. Radio frequency. This is the fundament of radio wave. I'm not talking about radar yet. Yes, because I wanted just to go directly to the radar yet, but God has told me that possibly you don't have these fundamental skills. So you have been just learning spectrums of light spectrums as separate, and then you'll be learning about infrared as separate, while you cannot separate them. Okay? So we use these 3 spectrums for the wireless. Say wireless communication. Wireless. You like wireless communication, eh? Do you like, ask your neighbor, do you like wireless communication or wired communication? So his or her choice is what? Wireless, eh? Yes. Or wired? Wireless. Wireless, eh? So you can be in Dar es Salaam and communicate with your father at gate. That's the goodness of wireless. But sometimes wired is very important. Yes. Okay. Just like myself, for me, I'm teaching wired and wireless. Say wired and wireless. Wired. So wired because I have physical student. So physical connection between a teacher and what? Student. Wireless by using the what? The power of the internet. There is no physical connection between who? A teacher and the? Yes, that's how. So if you ask me, how did you apply telecommunication engineering in your life? I tell you, just to check my teaching, how I have integrated telecommunication engineering. Do you appreciate? Okay. Yeah, yes, give it up. Thank you, thank you. So radio frequency, we use radio frequency for the wireless communication. We use microwave for the wireless communication. We use infrared for the wireless communication. So let me just give you some practical examples of radio frequency. The first are practical. For instance, this is my mobile phone. If I want to communicate with a nearby base transceiver station, aka BTS, right? So actually my mobile phones will propagate the information from here to the BTS at the DIT pitch, right? Because we have a BTS there. And then, so it means the radio frequency is the one which will be propagated by these mobile phones toward the base station. If somebody calls me or send a message to me, and then there's a radio communication or radio frequency communication between my mobile phone and the nearby base transceiver station. Is it clear? Yes. Yeah. So if somebody asks you, give me one example of who use radio frequency. Say, okay, cellular communication. I say it, stop writing. The second example, microwave. Say microwave. Microwave. Say microwave. Microwave. We used to buy something called a bundle. Internet band, right? Yes. So microwave, we use microwave in cellular or microwave dishes to provide the quick internet. And the size, the radio frequency, the type of the antenna for the radio frequency when you visit the telecommunication towers or you visit the BTS, it is, we have actual that because you have monopole and then also you have dipole. But in case that the dish will be used, these are the large dishes. Large dishes use radio frequency, right? But in case of the microwave, you can see microwave dishes in most of telecommunication towers or beaches, because the size of, first of all, microwave use dish antenna. Say dish antenna. And then we don't mean about satellite antenna, satellite dish antenna. No, the size for the dish of microwave antennas is very small. I think that we have there in my office, but I'm not teaching you about microwaves and whatever. We have. It's very small. So whenever you see a telecommunication tower, you will see dishes which have been actually presented in forms of drums. You see a large drum and a smaller drum, right? So those large drums for the radio frequency communication. Those smaller one for the OT microwave link. We call it microwave link because microwave use line to line, means a line to line communications or link. The one microwave dish has to be in line with another microwave dish. Otherwise, there's no communication. For the radio frequency, most of the antennas of radio frequency are omnidirectional. They can propagate information. They can propagate the information in terms of 40 in 360 degrees. Are we together? Yes. Yeah. So, if somebody will ask you that, how are you using microwave spectrum? Wonderful. Then ask him, my friend, are you using the internet? Yeah. There is no internet communication without the microwave dishes. Simple like that. Okay? For instance, for us who are older more than you, the internet communications by that time, previous was called the GPRS. Before we have second generation, before we had, or maybe we have 2G, before we had 3G, before we had 4G, which is LTE, and even before having nowadays 45G. Are we together? Yes. Then we come for what? Infrared. Say infrared. Okay, ask your neighbor, have you ever seen a remote? Either air conditioner remote, or television receiver remote, or radio remote. So ask your neighbor. You have seen a remote, yeah? A remote to turn on and off, to switch on and switch off. For instance, a television receiver at home. Do you have a television receiver? Yes, even if you don't have at home, but you used to go and check the football by nearby OT, we call them actually that video centers. So you see the owner of the OT, of the center, actual tuning and the changing the stations, etc., etc. So the communication, actually that, the communication between the remote and the air condition, it's wireless. And there we are not using radio frequency, we are not using microwave, we are using infrared. So the radio, the remote transmitting electromagnetic waves in the frequency and wavelengths of the infrared. Then the air conditioner, for instance, this one, it has IR receiver or infrared receiver. So the remote, it's a transmitter. And then that one's air conditioner machine, it has what? Receiver. Are we together? Yeah, so these are the practicals, electromagnetic spectrum. Is it clear? Yes. Then we still have another spectrum which I mentioned, but we did not discuss, which is visible, right? So we say that this one, these are the print to note in your life, for the rest of your life in telecommunication. Number 1, number 2, number 3. In telecommunication, the one that you are doing, or you like, I know that you like telecommunication engineering more than electronics. In telecommunication engineering, we use only one spectrum of light for the guided, or you call it wired. What are you talking with your neighbor? Are you talking about what? IR. Wired communication. Which is Visible light. So also in guided, say guided. In guided communication, we use also electromagnetic waves or electromagnetic light to transmit information from transmitter to the OT. When you say we use electromagnetic lights, it means that electromagnetic lights, it's a one that we call it medium. Medium of OT, of communication. So for this case, we are just using only visible light for the wired or guided OT communication. Are we together? Where are we using that visible lights? The answer is very simple, because you have a module that which will teach you in this second semester about propagation and the materials that will be propagating that visible light, which you call the optic fiber. Optic fiber. So remember that. So we say that visible light is used in what? It's used in optic fiber communication. It's used in optic fiber communication. So what you are transmitting through the fiber or the optic fiber, it's a visible light. It's not radio frequency, it's not infrared, it's not microwave, it's not X-ray, it's not UV light, it's not gamma rays. Are we together? Are we together? Yeah. So possibly if you have never known about that, then that's what you have to know as telecommunication technician. These are the simple information and important information for any serious and practical technician in optic fiber OT communication. So yes, so that's all about visible light. Yes, I think it is. Yeah, that's all. So remember that mostly modern telecommunication system have integration between guided and the unguided communication. Did you hear what I said? What did they say? You just heard most. Then after most, you forgot. After most, you heard guided and unguided. But just what happened or what I said, possible that you haven't heard. Let me repeat. Modern telecommunication system integrate both guided and the unguided medium. Why? Because guided media has some more advantages over unguided communication in some of the scenarios. And also, guided or unguided communication has some advantages over guided in some scenarios. So it depends on the scenario. So before I write that sentence, let me give you a simple example. For instance, take your mobile phone. Take your mobile phone. And then call somebody. Try to call somebody who is far. Try to call somebody who is in Kigoma or Geita or Kagera. Take your mobile phone. When they say take your mobile phone, every student has to take a mobile phone. And then try to call anybody in Lake Zone or in Tanganyika Zone or in Mbeya or in Lindi, somebody who is far, physically far from the place where you are. Then she'll make a call. Listen, the issue is not to make a call. Listen, I want to show you the secret. The issue is not to make a call. You usually used to make a call, but I want to tell you that you used to make a call without the concepts of telecommunication technician. You make a call, but you don't involve your understanding and what you've been learning in class on, and to see and to notice its application. Whenever you make a call, there are some delay before the phone rings. Whenever you make a call, there are some delays in terms of seconds until you hear toot, toot, toot. So for you, once you hear toot, toot, or before you hear maybe a reply that the phone number you're calling is not reachable. There are some delay. So notice that delay today. How many seconds? That day today is practical. Make a call and then check your stopwatch and then measure. How long does it take until signaling between transmitter and receiver has been established? Because that's what we call signaling. That toot, toot, or the number you are calling is not Richard. That is all about signaling. So some of the students did it. How many seconds? 7 seconds. Others? 4 by estimation, or you measured? You measured. Good. This part, these guys are still chatting. They're in WhatsApp. So you can cooperate. One student is making a call, the other one is starting and stopping the stopwatch. So one group, they said it takes 7 seconds. The other ones, holiness, say 4 seconds. Others? Don't estimate and don't assume. Maybe 5. And now? 4 seconds. So some other students have got it 4 seconds. Comba? 2 seconds. 2 seconds. Godfrey? Godfrey is not in the class. My sister there, I asked you that to be on this side, but you have forgotten. So, my friend there, the tallest guy in this class. 9 seconds. So the tallest students in our class say that 9 seconds. There, my sisters there. 5 seconds. This is the practical. Tell your neighbor, that is telecommunication practical. You? 4 seconds. So how many experiments, how many values, how many numbers do you have? 1, 2, 3, 4, 5, 6, 7, right? Yeah. Then add them and divide by 7. Let us find the average. 9. Take 7 plus 4 plus 4 plus 2 plus 9 plus 5 plus 4 divided by 7. 5. 5. So it means that the delay time is 5 seconds. In average, right? So do you know what is happening within those 5 seconds? You know what is happening. Can you tell us? Because there is no any moments when you make a call and the phone, the signal is established or the connection is established. No. There are some delay. So do you know what is happening? Every day, whenever you make a call, do you know as a telecommunication technician, what's happening within those 5 seconds? To establish connection. How that connection is established from here to Mbeya? Do you know that if you want to go physically from here to Mbeya, how many hours will you spend? Or maybe from here to Mwanza. How many hours? Or to Mara. How many hours? From Dar es Salaam to Mara. How many hours are you going to spend? Almost a day. Almost a day. So for you, if you travel, the bus uses a day. But the call uses just 5 seconds. And it uses 5 seconds, go and return. So think. What is happening there? So discuss with your neighbor, because I see that just you are filling up the air. You are breathing carbon dioxide more than taking the oxygen. Discuss with your neighbor. What do you think? What is happening? Okay, so for the online students, you may discuss yourself if you're alone. Try to think what is happening within those 5 seconds. So let us end our discussion. Did you find something from your neighbor? No. Okay. Good. So next time you have to be careful about your choice of the neighbor. Okay, listen. Previously, when we have been using telephone to communicate, you may call somebody and you have to wait an hour until the connection is established. You have to wait? So if you call somebody, not even just in Kigoma, if, for instance, you are here at the Ministry of Technology, you want to call somebody actually in Kariako or at Kariako, you may spend an hour to establish the connection. That's the history of 40 telephone, or called telephone network. Okay? But nowadays, regardless of whether maybe in Mwanza or whether in Dar es Salaam, you just need 5 seconds, then the connection has been established. Whenever that you, in telecommunication, you have something we call T-signaling, and also we have something that we say that the communication. So signaling actually is establishing the network. Right? It's just like yourself, if you want to travel from here to Mwanza, you should find some buses which establish the journey from here to Mwanza. Right? Otherwise, you cannot travel to Mwanza. Are we together? The same protocol or the same philosophy is used in telecommunication. Before you transmit or you allow the information to be transmitted, you should establish the network. You should establish the path. If the path is not established, no transmission of the information. Simple like that. Are we together? It's just like when God wanted to put a mankind on the earth planet. He created the environment first for the 5 days. And then the 6th day, he created the mankind, who we are, the output. We are the, call them, so we are the offspring. Okay, so within these 5 seconds, remember that when you make a call, or when you be making a call, the cellular antenna within your mobile phone propagated electromagnetic radio frequency to the nearby base station. Are we together? Then that nearby base stations received the information and then used to send that information, which we call the signaling, that information to the, we call them to the cellular main switching center. For instance, you used to hear that we have Voda center, Airtel center. So the headquarters, where the headquarters, or we call this, that there's a central OT, a central switch. So now, propagation of the information from the nearby base station towards the central switching station might be done by using the microwave dish links, but mostly often it is used that communication between the BTS and the central switch is being accomplished by fiber. Are we together? Why? Because fiber transmits informations with a very high speed compared even to the RF. Once the call, the signal has been or has reached to the main switching center of the particular place, then that actual data, what will happen? Your signaling or your signal will be thrown to the entire network, or to the, actually say that to the central network of Tanzania, in order to search the particular destination. But simply, maybe some information that I'm teaching you are a little bit advanced. But simply, what is happening? So you have the signal has been sent to the Voda switching center, central switching center, or national switching center in Dar es Salaam. Then that signal will be sent straight forward to Mwanza by using fiber. Okay? Then once it's Mwanza, Mwanza also has different districts. So the search will be done to find the destination number. Maybe the district is what? Ilemela. So the information will be sent to the switching center of Ilemela. Okay? Then Ilemela also have different words. So each word has its own switching center or basic, BTS. So then the particular BTS will be phone, because the BTS always receive queries and reply. So, for instance, I can ask you, BTS X, do you have a phone? Do you know this phone number? Then say yes. Belongs to who? Sophia. Is Sophia in your area? No. So the process of communications is very interesting if you understand. But if you don't understand, you'll be just a telecommunication user. So within these 5 seconds, the signal has been sent to the nearby BTS, has been sent to the central switching center, has been sent to Mwanda, and then you have received the reply. Why is it fast? Because of integration between the guided communication, unguided communication, and guided communication and unguided. For instance, fiber transmit information by using the speed of light, which is 3 exponent 8 meter per second. Do you know 3 exponent 8 meter per second? This means that fiber or optic fiber propagate the signal at the distance of 3 exponent 60 kilometer in 1 second. Hey! Listen, these are very important materials. So maybe you did not understand about 3 exponent 5. 3 exponent 5 kilometer per second. So 3 exponent 5 kilometers per second. This simply, if you write the speed of light, it is 300,000 kilometers per second. So fiber or optic fiber propagate the information propagate the information in a distance from one point to the another point, which the distance between those 2 points is 300,000 kilometers in 1 second. So from here to Mwanza, how many kilometers? Almost 500 kilometers. So 500 kilometers is just a subset of that. Because you used to learn fiber, optic fiber, you used to do splicing, but you have never thought. You have never took time. The speed of light, 3 exponent 8 meter per second. Then you go. During O level, you have been learning materials in that style. Even now, you're specializing. You don't even take your time to think. So there is no any region which is far from, in Tanzania, which is far from Dar es Salaam by this distance. Okay? Okay? So let's say that from here, let us assume, from here to Mwanda, let us assume, or from here to Mara, from Dar es Salaam to Mara, is 600, or let's say 700 kilometers. So how many seconds will the optic fiber propagate the information from Dar es Salaam to Mara? A fraction of a second. Because if you want to determine the time, you just take 300,000 divided by 700. Are we together? Are we together? So you can find that the optic fiber can propagate the information to the farthest destination within 0.0001 second. That's why the network will be established within a short time. If you use radio link, the delay might be higher than the one you have noticed. Are we together? Yes. Are we together? Yes. Yeah, you have been learning fiber and you have a multi-coded fiber, but you have never thought in that. So this is the fourth note. Say that in designing in telecommunication, engineering, we integrate guided or wireless communication system with, this is unguided, sorry, wired. Wired communication system with unguided, which you call it wireless. Wireless communication system. So we integrate guided with unguided communications, guided communication system with unguided communication system to design modern and a fast telecommunication system. So system to design modern and fast telecommunication system. That's why that you may send an email from Tanzania to your friend in USA and just take few seconds to reach the destination. You have never thought about that. Why? Because you don't like what you are studying about. Simple like that. Because you have to ask yourself, I just sent an email from here to USA. Then within maybe 2 or 3 seconds or 5 seconds, then I received a reply. What happened? From here to USA, how many days will I spend if I go on foot? I will never arrive there, right? If I use an airplane, it's a number of hours. If you're using a bus or bajaji, can you take a bajaji from here to USA? Because you used to say that. Can you use boda boda? You can't. But sending the information within just a few seconds, the information reached the destination. All the countries in the world and all the continents are connected by optic fiber. We call them backbone network. Are we together? Backbone network. Say backbone network. So if the backbone network or the intercontinental backbone fiber network fail, there is no communication. Especially for us who are third world countries. Because some of the developed countries, they use satellite to provide cellular communication and internet communication. For we are still using fiber. So our fiber, in case our fiber fail, we don't have any internet. Simple like that. The entire country. And maybe you'll be on charge at TTCL or there. So we'll ask you, how can you figure out that problem? Then you say, let me go to do BNG first, then I will come back. Class, is it clear? Yes. Okay. Did you understand? Yes. Eh? Yes. Okay. So this is a fundamental concept you should have about communication. Now, let me teach you about now radio frequencies. So did you understand the concepts of radio frequency? Eh? Good. So radio frequencies, let me teach you some radio frequencies used in radar system. In radar system. So in radar system, we use some radio frequencies. And I found 3 of them. So in order for you to understand about the radio frequency we use in radar system. So here we get a question. This is question number 4. What are the examples? What are the examples of radio frequencies? What are the examples of radio frequencies used in radar system. Used in radar system. So what are the examples of radio frequency uses used in radar system? So the following are some examples. The first one, we say that in radar system, remember that we have radar system for the different uses. We don't have radar system which is universal. So for instance, for air surveillance, we have a radar special for that. We have radar system special for weather. Hey, stop writing. Whenever I talk that you have to stop writing. Yes, what? Listen, what I'm telling you, I'm not going to write. You have to listen. Your receiver has to be, because when you are writing, you are transmitting. So your receiver should be on. So because you forgot to turn on your receiver, that's why that I have to apply external force. Because for you, you are applying the first Newton law. Everybody continue in the state of rest or motion in a straight line. Whenever there is an external acting on duty. So whenever you hear, hey, it means that there's external force. Because you were somewhere. And I know that where were you? Okay, I say it, and I'd like to say, we don't have universal radar, that a radar which can be used in all the applications that we need to use radar. Okay? So radar systems are made for the particular purpose. And I gave you some examples. Radars are used for air surveillance, to protect the airspace. So there is a particular radar for the air surveillance. Are you together? Radars are used for the water surveillance, especially ocean surveillance. There's a special radar for the ocean surveillance. Radar also are used for air transportation. By using airplanes, by using jets, by using helicopters, there is a special radar for the air transport. Radars also are used for, actually for what? For the boats and ships to cross, actually to travel through the ocean. So the particular radar for that particular purpose. Radars also are used in weather forecasting. For instance, you have TMA, Tanzania Meteorological Authority. They are using radar to forecast. That's why if they tell you tomorrow it will rain in some areas in Dar es Salaam, then you say, radar, utabiri wa hali ya hewa in Bongo. Then you come, once you reach at Magomeni, they'll tell you that you change the route. Why? You cannot cross Jangwan River. But yesterday, you heard it. Then you ignored it. What will happen? You might go back home, or you might spend 3 to 4 hours to arrive your final destination. Are we together? Are we together? Yes. Are we together? Yes. Okay. So, radars for air surveillance. Radars for air surveillance. Air surveillance. Air surveillance. Radars for air surveillance. And the air distance. And the air defense. Radars for air surveillance and the air defense operate in very high frequency. Very high frequency. In short, we call it VHF. VHF band. VHF band from 30 megahertz to 300 megahertz. Say radars for air surveillance. Radars for air defense. So they operate in which frequency? Very high frequency. Say very high frequency. In short, we call TOT? Pardon? Pardon? Again? Again? Very important information. Ask your neighbor, when you get your firstborn, are you going to call him or her VHF? Because when you call him or her VHF, possibly, he or she might be a very good and a technical telecommunication technician more than you. You say no, you don't want your children to be telecom engineers. You want them to be who? Politicians. Politicians or secretaries. So radars for air surveillance and air defense operate in very high frequency. Say very high frequency. From 30 megahertz to 300 megahertz. I told you that numbers are very meaningful in engineering. Okay? So let me ask you, for instance in Tanzania, where do we have air defense force? Air defense force. Say air defense force. Air defense. Where do we have it? Air defense force. Do you know its camp or the air camp? Air defense army. Maybe the defense force for you don't understand what does it mean. Air defense army. Where do we have them? We have them at Kipawa or Mwalimu au Jainia, Mwalimu Julius Kambarage Nyerere. When you say air defense force or when you say air defense army in Swahili, because possibly that is a vocabulary for some of us, especially who are come from Swahili speaker school, we mean jeshi la anga. We don't mean about polisi. We don't mean about field force. No. Jeshi la. Okay, say jeshi la anga. So, in case of Tanzania, we have them at Kipawa, or simply called Jainia, Julius Kambarage Nyerere International Airport. We have a number of them there, and they have the camp. But also, the headquarters of Air Defense Force in our country, it is located in Kizuka, Ngerengere, Morogoro. Okay? So the Air Defense Force, they have a special radar for the air surveillance. If you want to know that they are at work, try to fly or try to cross this border, the air atmosphere or the air borders of Tanzania without the air permission. Then we'll enjoy them. Are we together? So they uses radars that operate in what? 30, from 30 what? Megahertz to what? 300? The second example. Modern air radar surveillance. So listen, those are the radars and the cheap radars. These are the expensive radars now. Modern, say modern. Say modern. Say modern. Ask your neighbor, are you classical or modern? So this is classical and cheap air surveillance and air defense radars. In case of the modern, and especially for the developed countries, we call them first world countries, they have very powerful radars. That's why, for instance, because nowadays there are, actually we say that we have air battles. We don't have physical battles until that maybe I said, we have air battles, means that I can conquer you when I'm located in my country. Right? And that's why whenever you listen from the radio, you can hear that maybe a particular developed countries actually that engaged or took control of a particular place within 5 minutes. So why? Because of the powerful radars and powerful instrument. So it's a modern air radars, surveillance with a long detection range. Say long detection range. So this one, they don't have long detection range because the detection range depends on the operation frequency or the operating frequency of the radar. Are we together? So for with this modern radar surveillance with a long detection range operates in the frequency range up to 2 gigahertz. 2. Remember the maximum operating frequency for this classical air surveillance and air defense radars is 300 megahertz. Between 300 megahertz and 2 gigahertz, which one is larger? 2 gigahertz, eh? 2 gigahertz is equal to how many megahertz? 2,000 megahertz. And 2 gigahertz is equal to how many hertz? 2 gigahertz is equal to how many hertz? 2 million? 2 million? Okay, 2 million hertz. Wonderful. Then, number 3. They said the example. The C band, which is 4, keep quiet, I'm about to end the class. We have also the C band radars. So we have the radars uses the C band which is 4 gigahertz to 80 gigahertz is used for weather radar and the monitoring the sea surface. So we have weather and we have weather radars which uses the C band. Say C band. These are very important telecommunication information. When here we have the C band, so you have to go and learn what the means of C band. So the C band, which gave you the range of the frequency, which it is 4 gigahertz to 8 gigahertz, this is used for weather monitoring and the sea surface monitoring. So these are powerful radars. Because you see, the operating frequency for this one, 2 gigahertz. And then for this one, from 4 gigahertz to 8 gigahertz. So which one, between this one and this one, which have a long detection range? So these we call the weather radar system and the sea surface radar system operate in C-band frequency, which is from 4 gigahertz to 8 gigahertz. So when you give you the range, it might be any frequency between 4 gigahertz and 8 gigahertz. Are we together? But remember that these are still what? Examples of radio frequency used in radar communication system. So this is what has been done and this is what it has been discovered. Ask your neighbor, when are you going to make a radar that operates with a frequency of 10 gigahertz. So ask your neighbor. That's a serious question. Homework 3. Homework 2. Explain briefly the meaning of range and the radio velocity in radar system, as used in radar system. So explain briefly the meaning of what? Range and the radio velocity as used in radar system. That's the homework, and I would like to say that this is the end of lecture 2. Yes, because I have been told that today it is enough. I think that today you got much more than other days, isn't it? Yes. Huh? Yes. Uh-huh. So that is good. Okay, so this is the end. Did you understand? Yes. Have you understood? Yes. Did you enjoy? Yes. Okay, let me appreciate you. So let us congratulate ourselves. Imara. Wow. Do you have any question? No. So thank you very much. In case you have any question, make sure to do the homework, because listen. The homework you are going to do is actual. We'll give you some information before lecture 3. So in lecture 3, we are going to cover about this stuff. So I just open your eyes and tell you what are we heading to. So you can go and do your private studies and get prepared and have a prior knowledge before we come and discuss together. Right? Yes. So if that's the case, thank you very much. See you in lecture 3.
Thank you. Mungu ibariki Tanzania, dumisha uhuru na umoja.